Hello learners, hope you are keeping well and I hope you smashed that half-yearly paper. I'm sure by now you're not thinking about the A, but even thinking about how high an A you can get. But welcome again. Today I'm going to look at climatology and I'm going to look at a few more questions. Now starting to zone into this climatology and the various types of questions. Once again, learners, just to go quickly through the checklist, what you need to look at. Again, we're going to discuss the mid-latitude and tropical cyclones under climate, your broad headings. Also looking at the subtropical anticyclone, you must have mastered all this by now. Also looking at the valley and the urban climates and integrating the synoptic maps in all of these sections. You'll have noticed from the papers and the exemplars, all these sections come out in all the different questions. None of these sections are left out. Anyway, let's get on to the important things, and that's the questions, because you know your content by now. I know you want to zone in on more and more questions, and we'll be covering that for you. Let's look at this first question that I have here, figure 1, all right, which you're going to refer to, and we're going to look at what the question does for us, or what the resource does for us first. Obviously, remember learners, I've always told you, you must look at the resource before the questions. So let's look at what it gives us here. We've got an important little thing here showing us which is north. Already we start thinking why north is there, its aspect of slope. Then we've got various little letters here showing us different activities in the valley floor. Then we've got the sides of the valley. Okay, quite a bit of information. We'll find out later if the D, B, and C gives us any sort of relevance to the questions. Then we've got an A here, which looks like a settlement. And already we're starting to pick up what the examiner is focusing on. For instance, we can see north. This is the north-facing slope down here. And we can see there's a lot of activity happening in this area. So settlement is basically on the north-facing slope. We've already picked up South Africa, and we've already picked up that the south-facing slopes, you understand, receive more sunlight. So I'm going to change this. All right, this is, the north-facing slope. I'm getting a bit old here. The north-facing slope receives more sunlight because that's north. It's facing north. And the south-facing slopes receive less sunlight. So aspect of slope is a very broad one here. Okay? And we can see in the activity there's some factories, etc. in the valley floor. So maybe possibly temperature inversion. But let's start looking at the questions. Define the terms. Can you see it already? We looked at our diagram and we see already we worked up aspects of slope. So define the term aspect of slope. Learners, I know you're jumping already. You know it's the angle at which the sun's rays strikes the slope. So it's the angle at which the sun's rays strikes the slope. That's your definition. One more point I want you to note, please, learners, and I'm saying this 100 times in all my programs, it's now 1 mark. Remember, a vague explanation, there's no marks. You must give it in full and you'll get your mark. All right, let's look at again temperature inversion. You must know the examiner is playing now with definitions, because he's going to lead on to further explanations. And your whole thing is going to be based on these major definitions. So you know already temperature inversion, eh? It's the opposite condition. Generally, the higher we go, the cooler it becomes. But now the higher we're going, the warmer it's becoming. All right, so we look at that definition. And we can see it's an increase in temperature. Increase in temperature with height. The opposite is happening. Already what's going through your minds, learners? Inversion layer. all right? Air subsiding, the inversion layer is warmer, the cold air, the air that's rising cools, but you're also thinking about valley winds, all right, katabatic flow. There's lots of ideas going through your head, all right? Let's look at this, the next one. Explain 2 reasons for the situation of settlement A. Now, learners, you already picked it up. By studying your resource, you've picked up again. If we look at this diagram here, why is A situated here? All right? Already we picked up 1 point. It's the north-facing slope. All right? So therefore, it's receiving more direct sunlight. Okay, because that's the north. So it's facing, the sun is coming through, it's shining directly. Also, when we look at the position, and I know I'm defacing this diagram, it's not right at the valley floor. It's towards the middle. What else did we learn, learners? That towards the middle, there's the thermal zone. The thermal zone. And I hope you deface your diagrams in exams like this, because you must have everything, you must make sense of it. It's the thermal zone, and the thermal zone is a warmer area. All right? Also, being higher up, we learned in the valley that there's frost on many occasions occur. All right? So therefore, it could be higher up to avoid the frost and the colder conditions. If there was a river there, it could be possibly flooding. So there's so many reasons that we could get just by looking at the diagram. So let's look at our answers again. It spoke about 2 reasons. All right, let's get my pen again. 2 reasons. And it says explain. When we start with explain, remember the difference in the mark allocation. Now, for each explanation, it's 2 marks. So let's look at it. As we looked at it, it is on the north-facing slope, which receives direct sunlight. It's warmer. People like to settle on the warmer slopes, especially if it's farming and things like that. Crops grow better. All right. Also, it is in the thermal belt zone, which is the warmest area of the valley. The thermal belt zone, which is the warmest area of the valley. All right. If learners, if you wrote things like frost, to avoid frost at the bottom of the valley, etc., depends, you must explain it fully. These are thinking out of the box. So give a proper explanation if you can't get 2, and those ones will also be accepted. Remember, it's 2 times 2 equals 4 because it's an explanation factor. All right. Let's look at the next one. Let's try and make sense of this question. During the night, pollution is trapped in the lower part of the valley. This is a nice question, right? Because it includes so many different aspects and you make sense of it. It takes that resource further, learners, that you don't only just get it from the resource, but now you apply it to your knowledge that you picked up in class. So let's look at night. Night, what gives us first? Lower temperature. What else? Because of lower temperature, more subsiding air. So we talk about subsiding air, greater amount of subsiding air. All right? So it's pushing that inversion layer or thermal zone lower down. And if it's pushing it lower down, and if there's pollution coming up, what's going to happen? All right? We're picturing this. So let's go back to our diagram. All right, I'm going to create something down here on the side. There's my valley. There's my inversion layer here where temperature inversion is happening. It's nighttime. So what's happening? There's more subsiding air. It's pushing this inversion layer lower. What's going to happen to the pollution from this factory? It's going to be trapped in here. So it's again your knowledge and using the diagram to work that out. Let's look at the question. Right, explain a reason or reasons for this occurrence. We know from the question, 2 marks each. It's 2 times 2, 2 factors or 2 reasons. Let's look at this. All right, the thermal inversion layer is well developed at night because it is cold, so it's well developed at night, and trapped by the cold air above. Remember, the air is subsiding, it's pushing the inversion layer down, so it traps the inversion layer lower down, and it keeps the pollution in there. All right, the thermal belt inversion layer traps the pollution and keeps them in the lower part because lots subsiding air. We've got other reasons. After dry, I'm going to cancel these little reasons down here, all right, because I do believe that this is for the following questions, and the gremlins have creeped in. You know, we always get those gremlins, but I'm going to take these first two, all right. That's 2 marks, and that's 2 marks. We've explained it about why there's more pollution near the surface. And let's get rid of this gremlins. Let's look at the next question, question 1.4. Explain the formation of frost pockets at the bottom of the valley. All right, again, related to the question here, there was a flow and all of a sudden frost came in, but you still should be able to handle it knowing the valley. Indirectly, learners, this is more a question that you studied and you just put in here. It's just the wording that seems to worry us. All right, but we know, I'm going to stop with my diagram now because I've damaged it too much. You know, all right, what happens at the bottom of the valley during the night? We have the katabatic flow and the air comes down. All right, you know, especially on a clear night and a cold night where this dry air comes down, and you've already learned that if temperature is, dew point temperature is below freezing point, the air has to reach the temperature below freezing point to reach dew point temperature, and if it's below freezing point, it's going to turn to ice crystals, and that's how we get frost. So let's look at the answer. All right. After a dry, clear night, cold night rather, the air drains down the slope, katabatic flow. If the dew point temperature is below freezing point, obviously it's going to, temperature will have to drop below freezing point, then it's going to condense or sublimate towards forming ice crystals, right? And that's how you get your frost. So we're going to look at it here. 2 marks, 2 marks. Remember, it was above freezing point. Obviously, no ice crystals are going to form. Okay? Below freezing point is your main factor. Okay, that's one on that. Let's look at another question. I'm getting really excited about this. I hope you are. All right, I'm going to take a different one. We did a diagram. Let's take a synoptic map now. All right, let's look at what we have on the synoptic map. All right, if we look at it, synoptic map, especially of our southern Africa, what do we have here? This you should know by now. Your cold front. Let's look at the temperatures or the pressure systems. I don't see much, and I think my age is getting a bit off here, but temperatures seem to be a bit on the lower side. But more important, let's look what's found or dominates the land, the high pressure system. Immediately that strikes you. High pressure system dominating the land, it is winter. You know, when the low pressure systems dominate the land, it is summer. Remember, those systems are there, but which one is dominant? Also, we can see that the high pressure systems have moved more in the northerly. If I had a bigger part of the synoptic map, you'd have seen it. It's allowing the cold front to come into the country. So this is ideal winter conditions, learners. All right, it already gave us a clue. I can't see much more here. All right, but you can see there's isobar readings, etc. The interval is 4 millibars. Okay, let's go on to the questions itself. Name pressure cell A. All right, now learners, we need to be careful here. I know this question was a bit vague. It came out in a past paper. I know many of you jumped to the word high pressure cell. If you're not sure about this, all right, whether they want the name of that high pressure cell or the word high pressure cell, learners write both. Right, high pressure cell, stroke, or right, high pressure cell, and dash or slash high pressure cell. But if you write the word high pressure cell in that, it's fine. Okay? But the reference here is made to that specific name of Kalahari high pressure system. All right? Kalahari or continental, the alternate name. All right, let's look at the next one. Explain the formation of pressure cell A. The formation of pressure cell A. You know already, it's associated with cold air subsiding down towards the earth, creating a high pressure system. You know these things already. It works for any high pressure system. All right, let's look at the answer here. I'm going to go a bit faster over these explanations so it gives me more time to do the analytical questions. As we know already, it forms when cold air sinks and subsides, creating a anticyclonic circulation. So it's sinking, all right, forming, the pressure is accumulating, and it's forming a high pressure system. All right, let's look at the next question. Name the pressure system that's likely to change the weather of Cape Town. It seems a long sort of question, but it's actually quite simple. All you have to look here and see which pressure system is coming in towards Cape Town. Obviously, there's your cold front, all right? So you know it's part of the mid-latitude cyclone. So you can write cold front, we'll accept it, or you write the word mid-latitude cyclone. All right, let's look at this. All right, I got cold front slash mid-latitude cyclone because it is a weather system. We'll accept both. That's just naming, so we got 1 mark. Obviously, for the explaining in the last question, it was 2 marks. All right, so we know that. Describe 3 weather conditions. Describe, obviously you interpreting it, it's 2 marks each, it's 6 marks. So obviously you learned it already. We were using the word describe. Sometimes we say analyze. It's actually any conditions you've learned from your notes or your class lessons, that what is the conditions of a cold front and the weather conditions and how it affects it. So it's very simple, guys. It's the same thing for any area. There will be a decrease in temperature, increase in wind speeds, all right, a cloud cover, precipitation, as shown down here. See, temperature drops, and we've got it here. Warm air rises, cumulonimbus clouds form, pressure decreases, humidity decreases, rainfall, possibility of thunderstorms, or you can write the word precipitation. Winds change to southwesterly because that's where it's coming from. Can you see it? It's coming from there, so the winds blow in from there. All right? Also, you must note that here you got this low pressure coming in. Also, the high pressure follows the low pressure to create that southwesterly movement. Remember, winds are named from the direction from which they come, not which they flow. All right, so we've got those reasons. Let's look at the next one. Explain the origin of Cyclone B. Learners, I've put this in purposely. We talk about the origin, and there's various things where it originates, what happens, how it develops. There's 2 marks here. All right, so you know there's about 3 or 4 points that you talk when you do about the origin. Writing 1 point will give you the 2 marks. We don't expect you to give the full explanation. Let's look at this. All right, 2.5. You know already about the polar front, etc. You know that warm mid-latitude air, all right, coming in. If I draw a little diagram here, you know you've got the 60-degree line there where there's your polar front, all right? And you know that already. There's warm air coming in from this direction towards it, right, from the equatorial regions and the mid-latitude. And there's cold air coming from the polar regions. That's your poles. And they meet at the polar front. That's what actually causes the polar front, and that causes the wave. Can you see it? Friction created along the polar front creates a wave-like formation. Remember you did that? Where you had that, your cold front, right, and your warm front, and then you had your wave-like disturbance, and that's when the fronts get separated, all right? Warm air is forced to rise, and the air begins to rotate in a clockwise position because the air is rising. When air ever rises, it creates a low pressure system. So you have a low pressure system, and that is why you have the clockwise circulation in the southern hemisphere. Now, learners, you know this. Remember, any one of these points will give you 2 marks. What evidence indicates that Cyclone B will move in a southeasterly direction? A very rare question, eh? All right, number 1. It doesn't come out often. One thing we could look at is look at the little, I call them thorns. Which way are they pointing? They're pointing southeasterly. That's one of the things to tell you. You understand? Another thing is that this high pressure system is here. How it's going to, as this is coming, it's going to push it in a southeasterly direction. It's going to form a little block here and push it in the southeasterly direction. That's your South Indian high. It's going to come in and block it and push it. So, let's look at the answer here. All right, the South Indian Mauritian high, as I've indicated to you, will force it southeast. It will push it. All right, the apex of the triangles on the front shows you that. I bet you many of you didn't know that one. Taught you something new today. There's the apex here. Can you see it? It's showing you that. I'm just teasing. I know you are brilliant. You know all these answers. All right, these are 2 different questions. Learners, we're going to take a small break because I've given you a lot of information to think about. Have that glass of water and come back. Hello learners, I hope you had that glass of water because we're in for more exciting stuff now. We're going to look at a different type of resource because looking at a variety of resources is going to improve your marks because you'll be ready for anything. So let's get going. Let's not waste time. All right, let's look at the resource we have here. It says examine figure 3. What is figure 3? All right, it could look like a cone with ice cream on it, but it's actually a tropical cyclone, as synoptic or satellite photograph of a tropical cyclone. We can actually see it. Okay, here it's beautiful. You can see how it's moving in. Can you see that? All right, it's actually clockwise. Southern hemisphere. Beautiful. All right, you can see towards the center how well the eye has formed. I love these things here, all right, to analyze them. All right, you see the tight band of clouds. And if I move the sea away, you'll actually see that little black spot, which is the little hole sort of thing where there's nothing happening. Clouds are clear because there's no clouds, hardly any precipitation. All right, so we picked up a lot already. The tight band of clouds around all these areas, it's back to clouds. All right, tells us already mature stage, eh? You understand? Because it can't be so tight like this. Southern hemisphere, because remember it's a low pressure. Air is less in the center. So we know southern hemisphere, air blows in a clockwise direction. Northern hemisphere, anti-clockwise direction. So a beautiful little cyclone. All right. There's not much information here, but there's so much we gathered from this already. We can already start pitching the cross section. I'm sorry, I'm using my eye. There's the 2 vortices on the side here. And my nose seems to be the one that's the eye, that's no cloud cover. Okay. Let's go on. Name the weather feature labeled A. You've already worked it out. You know it already. All right, the feature labeled A is and I'm going to go through again, is a tropical cyclone. All right, we accepted the word hurricane. All right, but the more correct one would be tropical cyclone because you worked it in the southern hemisphere. Your 1 mark. I'm not going to waste so much time on the simple ones, so I can have more time in the program to explain you the analytical ones. Identify feature C. You've already picked it up, learners. That is the eye feature C is the eye. Because it's a straight identification, it is 1 mark. State 3 weather conditions associated with C. Learners, what have you picked up here? Knowing your features, knowing how to identify your features make a big difference. This is sort of scaffolding questions, take you from a simple to a more difficult. And remember, if you did not recognize the eye and you recognize it incorrectly, you're going to lose these marks here. So identifying your features and practicing with resources makes a big, big difference. So I knew it's the eye. Already this question becomes very simple for me. I know calm conditions, clear skies, high humidity, high temperatures, lack of precipitation. All right, all those things just come to my head. It's so easy to interpret. Let's look at the answers here. Already, you know them already. Your calm conditions, all right, clear skies, high temperatures, high humidity. I got even there's so many, you just know them off. Each one for 1 mark. And you got your 3 marks. Explain why weather C is associated with these weather conditions. Can you see we call them scaffolding? Simple. Again, a little higher, and now we're going higher. We're saying, why does this area experience these weather conditions? Remember, you picked up the eye when we've done it, and you know you had your cloud cover, all right? And you had rising air here. All right, very little subsiding, but you do have a certain amount subsiding there, which does not allow for condensation happening here. Because as the air rises, and even the air that rises, it diverges and subsides. So because the air is continuously rising, also there's a bit of subsiding air coming in. So when this air rises, it does not condense. It just moves out. That's what creates your clear conditions, etc. Because you have to reach a certain dew point temperature for it to condense. All right, let's look at the answers. All right. The upward spiraling movement. That was beautiful how it moved on its own. All right, I enjoy that one. All right, it's moving up. So the upward spiraling movement of air creates artificial wall around it. There's it spiraling and going up. You understand? And there's your cloud formation as it's diverging. So it creates a sort of wall, all right, around the center. The small column of subsiding air in the center, remember, it's hot here, so only little subsides. By the time it subsides also, it heats up and it's pushed out, all right, prevents the surface air from rising and cooling to such a level. Remember, it rises, but the only time it will cool when it reaches dew point temperature. So it prevents it from rising to such an extent that it cools down to dew point temperature and forms a cloud. It keeps it there, all right? And then your divergence happens there. Thus, no condensation happens. So visualizing that, it stops it before it condenses, all right? It keeps it there. No condensation happens. If no condensation, no rain, the temperatures still remain warm, calm conditions happen. Beautiful in the eye, eh? Totally calm while destruction is happening around it. Of course, any 2 would give you the marks. This was in a paper, please note, all right? Sorry, I changed it. It should have been 2 times 2 equals 4, all right? Which would have given you 2 marks for each explanation. All right, let's look at the next question. Give 2 reasons why these weather features are called destructive features. You've already studied you. Again, if you identified it as a tropical cyclone, this answer becomes easy, learners, because you know strong winds, destroys infrastructure, heavy rains, floods areas. So it's destructive. No tropical cyclone is going to be something that is generally good for any country. All right, so be thankful. Don't be unhappy that we don't get tropical cyclones. Not many of them hit South Africa, because it can be very, very destructive. All right, can you see they're associated with strong winds? We can get winds over 200 kilometers an hour, and that's very fast, even faster than my skoro. All right, strong winds destroy infrastructure and buildings, roads, buildings, houses, especially in the informal settlements. It's terrible. All right, associated with thunderstorms or torrential rainfall, massive amounts of rainfall for a long period of time. Floods, all right, okay, especially in the coastal areas. We talk about storm surges. All of a sudden, we've got this huge clouds coming in, causing massive rainfall over the area. So that is why they are destructive. Any two of this would give you your total of 4 marks. Let's go to 3.6. Is the system in the mature or formative stage? Obviously, when you looked at this, learners, we already identified this is tide band of clouds. Also, the eye has formed. And you've learned in the formative stage, there's no eye. Even if I didn't do the clouds, you saw the eye immediately. Between formative and mature, you know it's the mature stage. All right, so our answer there very quickly is your mature stage. All right, and the reason, that's 1 mark for that, the reason the eye is present, or tight band of clouds, but the most obvious one is the eye is present down there. All right, so that's on the synoptic map. Let's look at another resource, another exciting resource. All right, and this is a cartoon. And it's often you get cartoons, and there's a strong chance you're going to get cartoons again. Do not literally just look at the cartoon. Do you understand? Look at what it's trying to tell you. Okay, can you see earth burning? All right? Okay, because we get some funny answers. We can say, somebody interpreted this before and mentioned that, look, the problem here is that these 2 men are fighting while this man's head is burning and he's going to die because they're not going to look after him. All right, that's literal meanings. We have to look further into it. What does it symbolize? So we can see earth burning, global warming. Not somebody's head just burning. I'm going to put it in short, global warming. This we see beyond the firemen. We see what's written. Developed countries. Can you see it here? So that one represents the developed countries. This fireman here represents the developing countries. I know it's big developing, but it's developing countries. This concept of big developing is actually quite simple. It's these big economics powerhouses like China, India. You understand, they're developing, but they are massive in terms of their economies. They rate in the top 20. China is number 2. So they're big developing countries. And you can see what's written here. COP out. You know, COP17 was held in South Africa 2 years ago, all right, where the environmental conference was held, big thing in South Africa. We see the word COP out, already telling you failure. So we picked up so much information from here, learners. Number 1, global warming. Number 2, the summit, COP17, which seems to be a failure. You already start thinking in your mind. You can see these 2, the developing and developed countries, not coming to an agreement. So that is why it's a failure. Can you see, just by simple things, I picked up so much. I am ready for the questions now. Can you see it again, learners? Very simply, and this is simple for you. No one should be getting this wrong now, learners. Define the term global warming. And I want to just emphasize one thing, learners. We get this year in and year out. Global warming is the increase in temperatures. That is wrong. That you're just saying a temperature for a specific day. It's higher than normal temperatures. Remember, it's a concept, so it can be different. Or I can say the increase in the average temperatures of the earth over a period of time. So higher than normal or average temperatures have to be mentioned, not just temperature. And we find this very often with our matriculants writing that and losing valuable marks. So please note that, learners. Let's go to the next one. Common argument between developed countries, that seems to be the between developed and developing countries and the big developed countries is evident in the cartoon. All right, that seems, let me just go through this quickly and check here. All right? The question itself, maybe there's a few words there. It's comment on the argument between the developed and developing countries, which is evident in the cartoon. All right? And if I look at the cartoon again, and COP17 is written above there. All right? It's written above here, and you can see they're arguing. Obviously, it's arguing about environmental challenges. And of course, remember the developed countries, they do not want to give in because they want to grow as economic powerhouses. And the developing countries are saying, whoa, we also want to become like you. Now you can't stop us. So there's a disagreement there. All right? So when we comment about it, we take it from there, from the article. No one wants to take the blame. All right? They're blaming one another, saying, no, you caused it. And the developed countries are saying, you caused it. It's not our fault because everybody wants to develop. They have different viewpoints, as I showed you. The developed countries want to develop further as an economic powerhouse, and the developing countries, on the other hand, are saying, hey, we need to become like you. We want to progress also, so you can't stop us. Okay, so it's basically your answer there is on the argument that's happening. But again, it's linking the cartoon to what you have studied. You've studied already this issue. It's not something new, all right? The disagreement between the two, and you know the reasons. So this gives you your 2 marks and your 2 marks. All right, there comes a famous one. Why is there a fire around the earth in the cartoon? And you know immediately, it shows the earth is heating up. It's not on fire, it's heating up. And it represents global warming. All right? So, our answer very clear there, because of global warming, rapid increase in temperatures. But the more correct answer here is, it's representing global warming. All right? What is a collective term for gases that cause global warming? Now, guys, already it's been given to you, you know this. And please, don't write carbon dioxide. We're talking about a collective term. We're talking about methane, which you give off, all right? We talk about carbon dioxide, from cars, carbon monoxide. All these terms put together, all right, is known as your greenhouse gas, all right? I'm going to change this to 1 mark, all right, because we're just giving one gas, which is 1 mark. Next question. Explain why the cartoonist Zafiro, well, that's the name of the cartoonist that did the cartoon, thinks COP17 is a waste of time. If you looked at the cartoon, he said cop out. He's given you a little hint there, isn't it? It's not getting anywhere. These people are not coming to an agreement down here. They're fighting and the earth situation is getting worse. So it's generally a waste of time. Learners, you're noticing that this little question is actually very enjoyable. You should be saying, give me that geography paper. I can't wait for it. It's so exciting. I want to answer it. You understand? So if we look at the answers here, no real commitment. Can you see it? As we discussed, and you know it already. From all countries participating, each looking at their personal gain, especially the developed countries. All right, it's a mere talk shop. That is why it's cop out. Now you're linking the information you learned to the cartoon. Cop out means no real participation. Okay? Emissions still go on because the earth is continuing to burn. You're not going outside the cartoon. You're interpreting the cartoon and give it here. No binding agreement. Those guys are still fighting. So all this you know. All you do is look at the cartoon and see if it's relevant there. You know the information. You studied it. See if I can fit it in. Don't just take things that don't fit into the cartoon that you've learned. Some people don't look at the resource. They just write the answers. Okay, learners, let's do one more. All right, I'm going to do one now on the city climate, a different section. Let's see a sort of typical question that we can get down here. Now, first of all, let's look at what is it portraying. Okay, we've got the CBD here, and then we've got a suburb here, we've got the forests, we've got the farmland. And we got a little graph. Now, sometimes the key for the graph is not given, but figures on the diagram can give you an indication what it is. We see it actually goes from here and it increases there and it goes down here. And we also got temperatures attached to it. So immediately we can not assume, even know that this line refers to the temperatures. What else we picked up from the diagram? This is directly above the CBD. All right, so we have this vertical extent, so it's hotter. Here at the farmland and at the forest, we can assume it's around 31 degrees Celsius. The temperatures are lower. Already, it becomes such a simple question, learners, you know it already. City climates, you understand, has higher temperatures because of the built-up structure, lack of vegetation, multiple reflections, cities' activities, industries, farmland made of more vegetation, more open spaces, more vegetation, therefore absorbing more heat for your photosynthesis, etc. So already all this information floods into your head. All right? So let's go for the questions. Simple. Can you see it? No diagrams are something that you can't work out. Let's look at the first one. Calculate the difference in temperature between the city center and the farmland. So instead of just saying to calculate, to define things, we can use things where we even make you look at the temperatures to identify, hey, that's city climate and this is rural areas and the temperature is different. We don't have to always give you a definition. So this is very simple, 35, 31. The difference is 4 degrees. All right? And if I looked at this down here very clearly, there we are, it's 4 degrees Celsius. All right, I can show the calculation, but the main thing is you got your 4 degrees Celsius as your difference. All right, so that would give you your 2 marks. Let's look at the next question. All right, give 2 reasons from the diagram why this temperature, 2 reasons from the diagram why this temperature difference occurs. Please note, you know tons of information. Please, learners, look at the diagram. All right? We already see the buildings. So, number 1, multiple reflections. We see there's a huge density of tarred surface. Here it's open fields. So, we talk about tarred surface absorbing heat. All right? We look at the density of buildings, lack of vegetation. Can we see it here? Yes. Can we see vegetation there? So look at what you see on the diagram. If it is not there, remember, learners, it'll be marked incorrect. And some of you got the habit of, you get so excited, I know this section, and you just start giving answers without reference to the resource material. So let's look at this answer here very quickly. Sometimes we do give a little out if it's not clear. Can you see? Geometric shapes, and we saw that increase the building, increase the surface area of heating. Here your multiple reflections come in. Building density traps the heat. Steel and concrete surfaces that absorb the heat. Multiple reflections of the buildings. Heat generating activities, cars, factories, air conditioners, etc. All right. Less plants in the center to reduce the heat. Remember photosynthesis. Pollutants above the city. This pollution layer lying above the city, it traps the heat. All right. Tall buildings prevent circulation, movement of the heat. It traps it. All right. Less evaporation to keep for air to have humid. So what is going to happen? Because there's less vegetation, less humidity, you understand. Therefore, the air is heated up when it comes through. So we have all these different factors which we can see. I worry a little bit about this one, but it's accepted because we see the vegetation and the tall buildings. But the rest of them, you can see clearly the trapping of the heat, etc. So look at your diagram and see what is relevant there. And obviously you got your 2 points, 2 marks. I've spoken a lot now. I'm sure even I made the director tired. And you must be tired. Get that glass of water and come back. Hello learners, you enjoyed your water? Okay, I'm going to go on to a different question. Please learners, I know some of it I'm covering, and then there's more questions we have available on that website. I've got more questions for you. So if you go onto the website for this program, you'll find there's a greater variety of questions. Please do, it will help you. But I want to get to a next type of question, a case study. You understand? Please note, a case study is not an article. An article gives you something generally about tropical cyclones. It is an article, but not the same. All right, it just gives you generally about what tropical cyclones is. A case study is a bit more specific, or it's a more specific article. It gives you a region where this happened. So please note that doing case studies, learners, will help you because you will get them. All right, so let's look at this case study, and I'm going to go through as quick as possible so that we can get through some questions. All right, figure 7, article and satellite image of Cyclone Irene. All right, already you're thinking A, B, C, D, E, F, G, H, I. 9 cyclones, eh? Already, can you see how we're interpreting it? 9 cyclones. All right, this was the article written by Lungelo. All right, Kyle Fenter, we have to give our reference. Okay, hundreds of families left homeless. Destruction. All right, destruction. I'm going to put a D here. Many roads and streets in Durban. Can you see it's a case study on a specific area? All right, that shows were damaged. Okay, another destruction. Other coastal areas north of the city, right to Cozy Bay, were turned into raging rivers. Flooded. Destruction. Showing you about it. You've studied all this. Irene caused chaos across the province of KwaZulu-Natal. The weather services said gale force southwesterly winds of 65 kilometers per hour were expected on Monday. All right? There was a strong warning of very rough seas. Okay? That was there. So there was a warning of rough seas. So this I wouldn't put as destruction, a warning. So there was something that said something there. It was a combination of rough seas, marine storm, surge, as well as gale force winds, massive destruction. And it threatened the coastline, a police spokesman said. All right? Colonel Vishnu Naidu, that's the names of the people which we have to quote because it's a case study. All right? Area household, the Josini, near Wanshadi area house collapsed and a woman breaking her legs damaged people's health and hurt them. All right. Okay. The KwaZulu-Natal floods hit on Sunday morning. Another problem here, learners. Look at this. It was said that on Monday it'll hit, but it hit on Sunday. Wrong warning, so it caused more destruction. Can you see how we're reading into the article? All right, the disaster teams were still quantifying the damage, but Naidu estimated to be about at least 300 houses have been flooded. So lots of information here that we picked up and gave us even a satellite photograph. You can see there's the coast of KZN, there's Durban here. There's a cyclone coming in, and you can see the nice cyclonic circulation. It's hammering across KZN. Also, some information is not clear, but there's a date here, there's a name, all right, which tells us it's happening in summer, and it's a tropical cyclone. Let's look at the questions. How many cyclones have, including Irene, have occurred? You know already. Cyclones are named according to the occurrence for that year. And I is the 9th letter. So obviously the 9th cyclone. All right. But more important, this has confirmed that about the tropical cyclone in the area. So it's 9. All right. Please note, learners, that it doesn't mean 9 has hit Durban. 9 has happened in the Indian Ocean where it's known as a tropical cyclone. All right, let's go to the next question. What evidence is there? Evidence on the satellite images suggests that Irene is a tropical cyclone. We covered that already, the tight band of clouds, the eye that's formed in the center. The name is also telling us it's a tropical cyclone. So, various of these things you worked out already. They're circular bands, all right? The name, the large diameter, indicated as tropical cyclone on the synoptic weather map. It wasn't very clear there, but it tells you it's a tropical cyclone. All right, there's many more I can go through here. All right, I'm going to change this to 1, so it becomes 1 mark because it's 1 there that tells us that. All right, the mark allocation is 1. But I could go through the whole list, which you're very familiar with, learners. All right, let's go to the next question, 7.3. State 2 conditions necessary for the formation of tropical cyclone. Now, it's a general question. Learners, whether it's KZN or whether it is the United States of America, whether it's Mozambique, it's the same conditions. Do not confuse yourself with that. All right? You've learned it. You know it. All right? Upper air divergence, etc. But let's go through that. All right? It's stuff you know already. All right? It's a state, so obviously 1 mark each. So, forms between 5 and 25 degrees north and south. You know Coriolis force is very limited at the equator. All right? We not see there's no relationship between KZN and this because we basically asked you for the conditions. You know about Coriolis force being limited at the equator. So for it to be deflected, for the recurving of the easterly winds, we need that. Unstable atmospheric conditions, you know that. If it's not unstable, air doesn't rise. If it's stable, air sinks. So how are you going to get a low pressure and a very low pressure if air does not rise? For convection to occur, all right, and the release of latent heat as it goes up, it cools, condenses, and therefore forms your cloud cover. But as it condenses, it's giving off heat. Sea surface temperatures above 26.5 degrees. Otherwise, you're not going to get that well-formed low pressure. Air must be rising all the time in order to get that low pressure. All right. Several days of calm. That's one beautiful thing, learners, in the sense that you cannot form a tropical cyclone overnight. Tropical cyclones take some time. You must remember that center, that eye must form. So air must keep on rising, and the temperature gets lower and lower and lower. And because it gets so low and the temperature on the outside is much higher, air rushes towards the center. All right? And therefore those speeds pick up. Okay, so several days of calm, upper air divergence. Remember that? If air does not diverge out of the eye all the time and all the air comes in, low pressure will die. Okay, so all these ones, I know I haven't done justice, only 2 points, but you can name them. We can even put a paragraph question on this. Okay, let's go to the next one. Explain why people in KwaZulu-Natal would not have been prepared for the chaos created by tropical cyclone. Number 1, you've already picked it up, learners. Remember we said it happened on Sunday, but it was predicted for Monday. All right, number 2, how many cyclones do we have in South Africa? Not many. So our early warning systems are not in place. Many people are even not exposed to the media, especially in the rural areas. So they didn't know. Our infrastructure doesn't cater for these strong tropical cyclones. So there's various answers down here. And if we look at our answers here, can you see? Unusual for KZN to experience this. KZN is too far south, and you know the temperatures are generally lower. All right? Oceans are too cool. Okay? Not as hot because we're heading towards the mid-latitudes. Poorly constructed infrastructure. Okay, our infrastructure don't mean that it's in a bad quality, but it's not sort of built to cater for these tropical cyclones. Our warning systems and evacuation procedures not put into place. Why should we spend millions when we don't have such big tropical cyclones hitting us? communications, lack of technology. There's various reasons. And if you gave any two of those reasons, right, it's 4 marks. Okay? Now, last little question. Write a paragraph explaining the impact of flooding caused by Irene on the economy and the environment. Look at this, 2 things here, economy and the environment. Please note, learners, you can explain 4 points, but it must include the economy and the environment. The impact, what damage is it causing to them? Let's look quickly before my time runs out for this little session. All right, I'm going to take a few little answers here. All right, impact on the economy, damage to infrastructure. How does it affect? You must know the cost. People don't go to work. Things stop operating to fix it. Beachfront properties, recreation is damaged. All right, loss of crops, which leads to food shortage, economic impact, more imports. All right, let's look at some of the, and there's various things here. You can check the website. They are there. All right, impact on the environment, loss of valuable topsoil because of erosion, disruption of the biodiversity, the different natural and fauna and flora is flooded, the wetlands are destroyed, food chains are disrupted. So there's various factors that are there for the economy and the environment, and we have to include both. We can have 3 of one of the other, 2 or 2. But they're not difficult questions. This is an examiner's memo or a marker's memo. You need to explain in more detail. I've overspent my time on this thing here, but I've enjoyed my session. All right, learners, all the best. Go back and hammer that A in climatology. Sharp, sharp.